what would be what you would be great is, first of all, I'll let you know that it's being recorded. So that's really helpful for everybody, that we can go back and you can look at this. So obviously, if you are making notes and so on, then it will be recorded and you can view it again to sort of catch up on things as well. Of course, we'll share with you the slides so you have that, and we'll do all that in a follow-up email. So it will be available afterwards. If you have joined us and you're quite comfortable using the chat function, then please make sure it's set to everyone, and just give us a quick hello. Just say hi. If you can't hear us, then I would suggest you just double check your connections, make sure your sound is on. If anybody else can't hear me, Kevin, I can see your message, but if anybody else can't hear me, then please put it in the chat, but hopefully you can. Yeah, that's good. So we've got some, great to see you all. Great, Kevin, you're sorted, fantastic. Brilliant stuff, guys. Lots of messages flying in from people up and down the country, which is brilliant. As I mentioned, for those of you just joining, my name is Martin Woodward. I'm the Club Business Manager here at the RFU, and it's my pleasure to host tonight. We have a number of guest speakers, and I'll introduce you to those just in a short while. As I mentioned, just keep just popping your name in the chat, saying hi, where you're from, and what your name is. Just getting used to that. And as I mentioned, if you can keep your chat to everyone, that'd be great. And we'll just give a number of people just a little bit more time just to join. Caroline, nice to see you from sunny Milton Keynes. Hopefully it was sunny today. Rich from Long Levens, welcome. Not a million miles away from myself in Cirencester. Good old rivals of ours, so welcome along. Okay, guys, so I think most people will have joined us from now, so I'm going to sort of take us through just some of the housekeeping, and I'll introduce you to our speakers as well. So first of all, welcome to our Tackling Energy Use in rugby clubs. That's the theme for tonight. We know, obviously, that in the current state of affairs, it's probably never been more as important, more pertinent than it is right now. So hopefully this evening will be helpful. There'll be an opportunity to ask questions as we move through. Use the chat function to do so. If we can't get to all the questions tonight, don't worry, we will take them away. We get a transcript of the questions and we can answer those, and we'll do that in a follow-up email, just so you have everything. So please, obviously, feel free to use the chat function. There will be a time when you can, but if there's something really pertinent and you want to pop it in the chat, then please do. So it looks like you're all great on the chat, and that's fabulous. So just make sure it is set to everyone. And you can see Alex, who's my colleague in the background, just putting a few comments in there saying, please add any comments and questions in there and make sure it's set to everybody so we can all enjoy them. And also, just to let you know, if you're looking at different types of devices, so a laptop or a tablet device or even a phone, you should be able to see and hear me, but just be aware there are a few polls tonight. So when the polls come up, certainly on a tablet, just make sure that you close the polls after you've clicked on the various responses and so on. Excellent. So we're nearly at 5 past. I'll just move on to the next slide. You'll be aware that live transcript is on, should you require that. So if you don't want to have that, you can hide it. And along the bottom, you should see the transcript icon, and just select that to click it off if it's already on there and you don't wish to have it, but please obviously have it should you require. And then in terms of tonight, so as I mentioned, never been as important as it probably is right now. And we're going to try and cover off a number of areas on the topics of energy use, efficiency and costs. And it's a large and sometimes quite a complex area, but tonight we'll provide you an insight with energy use at a rugby club, ideas around energy efficiency, some renewable energy sources, We'll also introduce you to our new commercial partner, Positive Energy. He'll be talking about the current state of the energy market and the government relief scheme, and also details of a free service that those guys will be offering to all rugby clubs. In terms of our speakers, I'm delighted to introduce from the Energy Savings Trust our first speaker, and I'll hand over to him shortly after I've just introduced the rest of the speakers. But our first speaker tonight is from the Energy Saving Trust, and he's one of their senior consultants. That's Ben Whittle. Just for those of you who are not 100% sure who the Energy Saving Trust are, they're an independent organisation working with individuals, businesses, communities, and they provide leadership and expertise to help deliver zero carbon strategy. And they've been really, really helpful working with us in this topic particularly. Ben's got a really comprehensive presentation for you. And as I mentioned, there'll be opportunity to ask questions, and anything we can't answer at that time, we'll take away and feedback to you as we go through. So just before I hand over to Ben, I'll also give you a quick introduction to representatives from Positive Energy. They're our latest commercial partner, and they're the UK's leading independent B2B, business-to-business energy supplier. And we're delighted to have with us Steve Daniels, who's the Chief Sales Officer and co-founder, and Sean Newbold, who's a director with responsibility for gas. Steve and Sean will talk to us towards the end of the presentation, and I'll give you an introduction to the Positive Energy and also the latest on the government scheme and their free service that they're going to be offering to clubs. So, just as I mentioned, we will have some polls. Please do get involved when they pop up. But without further ado, Ben, I'm going to pass over to you. I'll go to mute and allow you to begin.
Great, thanks, Martin. My name is Ben Whittle. I work for the Energy Saving Trust. I've been working there for about 3 years now, and I've got a 20-year background in renewable energy and energy modelling. The first thing I'd like to do is just really apologise for the bad pun in the title of the presentation here. I never thought Martin would agree to it, but he did. So today we're going to be covering energy use in clubs, energy costs, energy efficiency, the possibilities around generating electricity with solar and how much it might realistically save on the bills, whether or not you might possibly be able to move over to heat pumps, whether that's sensible or not, and how you can get extra value for money by mixing solar and heat pumps together if that is a practical solution for your club. And then at the end, we'll have the questions and answers session. First off, we're going to start off with a poll, which I think Alex is going to bring in for you there. And the poll question is, how concerned are you about energy bills for your club? On a rating of 1 to 10, with 10 being very concerned and 1 is not concerned.
Yeah, let us know, please. That poll is with you now. I can see lots of people have already jumped in. So please do let us know your answers. If for any reason it hasn't popped up, do push your answer into the chat function for us. But I can see, you know, a hell of a lot have already completed it. I'm just going to give it a few more seconds and then I will show you the results about what people are feeling. We've got around about 100 on the webinar tonight. So just that final bit, and I'm going to end that poll now. And I'll share those results with you. And I don't think there's any surprise there, Ben. You know, 57% are 10 are very concerned, with another 30% at 8 and 9 and stuff. But majority of people are very concerned about it. Over to you, Ben.
Great, thank you. Okay, so I'm just going to set the scene a little bit about heat and electricity use in buildings. On the left-hand side of this screen with the pink and blue, we've got a house, and on the right-hand side, we've got a club. I should probably just start off by saying here that when I start talking about energy use in clubs here, I've got this from actual data from one of your clubs. So I'll talk about that a little bit more, but most of this comes from Tyndale. And just a big thank you to Jonathan Arnold for coming up with all the facts and figures that I needed to help create this presentation. So you can see here on the left that a house, about 17% of the energy used in the house is electricity and about 83% heat and hot water. What you're seeing with the larger circle is the proportion of energy use. And on the bottom left-hand side and the smaller circle is what that split is, but in cost rather than in energy use, because obviously gas and electricity cost different amounts. And obviously the same thing on the right hand side again. The big circle is the split of energy use, electricity and heat and hot water. Vast majority of it is still heat and hot water, but the electricity usage is much higher for various reasons. So the figures and graphs that we see on the next few slides will be all about avoidable costs. So I haven't actually put the standing charges and so on into this pricing statistics. They're just based on what you can potentially avoid. This is the gas bill for Pinedale over the last year. You can see, maybe unsurprisingly, that it changes quite dramatically over the course of the year. Very little in the summer period, quite a lot in the winter period. And the red dotted line is telling you cumulatively what the bill adds up to over the course of the year. And by the time we get to the end of the year in December, the bills have totaled up to around about 2,750, something like that. Again, this is avoiding standing charges. If we look at the electricity bills, we've got a very different picture here, and you can see I've got lots of different colored bars going on there. That's because there's 4 different connection points at the club, so 4 different sets of bills coming in. You can see the key at the bottom there. So there's a weekday rate, a weeknight rate, another meter somewhere else with single rate, and then the floodlights are also powered by their own meter as well. Supplied by their own meter as well. So all of those added up give you that shape. The rather unusual blip that you get in the middle of the year there at June is a result of external events where the premises have been hired out to other people, I believe. So that's what's causing that spike. Otherwise, we'd expect it to be the same as May and July normally. Sorry, I should just go back and explain. The cumulative bill there at the end there is about £9,500. In the future, we're moving into this new situation with the energy bill relief scheme, which is helpful for businesses and other domestic, non-domestic customers. You've got the rates set there on the slide. Not many people understand what megawatt hours are, so I've converted it into units for you down at the bottom there. That's 21 pence a unit for electricity, 7.5 pence a unit for gas. That is about 30% cheaper than what the domestic price caps are at the moment. So it is cheaper than houses, but it's nowhere near as cheap as where it was earlier on in the year. And if we look at before and after, so the situation we're in from the bill set that I got given by Jonathan, moving through to the new regime, you can see the dotted line there is showing you where the gas bill is going to go up next year with those that energy support relief in place. I know it doesn't sound like relief when it's going up so much, but obviously it's a lot better than it could be. So there's going to be really, really significant rises in gas bills going forward. Previously, the cumulative bill was around about £3,000 for the year. It's going to be approaching £7,000 for the year into the new regime. We do the same thing again with the electricity use. I've just summed all of those different meters together, so it's a bit less confusing to look at. The cumulative bill before was, like I said, just about £9,000. Going into the new regime, it's much more likely to be closer to £12,500. And don't forget, there's the standing charges added on top of that as well. So what's happened from before to afterwards? We've seen gas increases go up by 248% and the electricity rate go up by about 140%. Pretty significant changes. So what are your options? Well, you've got energy efficiency, electricity generation from solar panels, heat bill reductions that might not come from energy efficiency. So you could be thinking about putting in heat pumps, and then you could further go towards even better savings by combining solar panels and heat pumps together at the same time. But that might not be suitable for everybody, and we'll talk about that in a little bit more detail. So we're going to go into another poll now. So back over to Alex. Do you know whether the support mechanism applies to you?
And I've launched that poll now, so you should see that and select one of them. Yes, no, or are you not sure about that? And I can see that they're coming in now. For any reason, I say again, if you cannot see it, please just put your answer into the chat function if you've lost it for some reason. So do you know whether the support mechanism applies to you? Yes, no, or not sure. Slowing up now, so I'm just going to give it a final bit of time before I finish this poll. So last little chance to get in. I'm going to end that poll now. I'll share those results with you. And a lot of you on the webinar tonight are not sure, with 56%, with some no and some yeses in there, Ben, as well, to add. Back over to you, Ben.
Great, thank you. So first of all, we're going to start talking about energy efficiency for heat. One of the problems we have with heat is very difficult to measure it. You can go and have a look at your gas meter, but that doesn't give you a good idea about how heat is being used or lost inside the building itself. When I had a look at the bills that I got sent through, I've had to do a little bit of guesswork to get to some of where I needed to. But this is basically the split of heat use inside the building. So the vast majority of it was space heating. I was quite surprised by this. I expected the showering, the energy used for showers to be really quite a lot higher than this, especially when Jonathan described exactly how many showers are getting used over the course of the weekend when you're in season. But you can see there what the breakdown is. And you can also see below that in yellow and green the difference between the showering energy used in the weekday for training and the Saturday in season, where obviously you've got a lot of visiting people coming and using your facilities as well. This is a floor plan of the Tyndale Club. You can see the layout of all of the shower heads over here and the lobby area. So I've used all of this in my modeling to try and work out what we should be doing about this. When you're trying to avoid wasting heat, the most important thing nearly always is to just make sure that something is not being heated when it shouldn't be. And when you are heating it, you're only heating it to the right temperature. So here we're thinking about timers to make sure that things aren't staying on when they shouldn't be. We could also talk about building insulation and pipe insulation and cylinder insulation, and then also about reducing temperatures on thermostats, hot water storage, and boiler temperatures. Now, in Tyndale's case, they don't have any hot water storage per se. All of the showering energy is coming through instantaneous combi boilers to provide that heat. So there's no stored hot water. That's probably quite a good move for a lot of rugby clubs because you're not there in the middle of the week a lot of the time using hot water, and it also avoids problems around keeping the water hot to reduce the risk of Legionella. So I understand why a lot of clubs would be using instantaneous boilers. That's not necessarily a bad idea, but there is also the issue of the boiler itself for heating the common areas, the lobby and the social lounges. I'm sure you have all heard that reducing the temperature of a building by 1 degree is enough to save 10% off the energy bill for heating. So that's a really good one to have stuck in your head all the time. It's probably one of the most important things you could possibly do to reduce your gas bill, reduce the temperature in the clubhouse if you can afford to do that. I know there is a lobby here. Maybe you might want to think about actually not heating the lobby if it's not strictly necessary. But there are so many different clubs out there with so many different physical arrangements. That's not a blanket statement for all clubs. I'm just asking you to think about the question. So when we think about timers, it's always a good idea to automate things, just like it's a good idea to have a light sensor on an outdoor light to make sure it doesn't turn on when it's light outside. You can do similar sorts of things with your heating controls. Theoretically, depending on how well organized you guys are and how active your facilities management is, you could completely automate all of your heating controls and actually do your control of the heating away from the building. So not only would you control time programs, but you could theoretically turn it on and off when there was nobody actually at the building and check whether the heating was on or off if you have the right heating controls in place that are connected to the internet. When it comes to insulation of buildings and pipework, building insulation is relatively expensive. Now, obviously, your occupation patterns in clubs are that you're using it mostly through the winter in season, but you might find that insulating the whole building would be a very, very expensive business, and it doesn't necessarily offer really, really good value for money in quite a short period. That's completely the opposite case for pipe insulation. Pipe insulation is really cheap and quick to do, and it will pay for itself in less than a couple of years most of the time. So when you're surveying your heating systems, you really want to be making sure that your pipes are insulated when they pass through cold areas. If you've got an uninsulated pipe in an area that you're keeping warm anyway, you might argue it's not quite so important to do that because the heat that comes off the pipe would just be heating the space anyway. But I imagine there are a fair number of club buildings that have got a boiler that's quite a long way off from where the social and lobby areas are, and it's passing through cold changing rooms and utility areas and so on. Those are the bits that you've really got to concentrate on and make sure those pipes are well insulated. Cylinder insulation. If you've got modern hot water storage, it should be well insulated already, but even a well insulated hot water cylinder can lose £55 worth of heat. If you've got an old poorly insulated cylinder, it could easily be losing 3, 4, or 5 times more than that. So that's also really important. If you're storing hot water for long periods of time, that's another big area where heat can be lost, and it just all adds up all the way through the year. If you are storing hot water in your facilities, your cylinders need to be kept at a safe temperature. So Legionella can breed in water temperatures up to about 50, 55 degrees Celsius. Once the temperature gets hotter than that, the Legionella will be killed by those temperatures. Ideally, you'll be keeping your hot water storage at 60 or higher. One thing I will say about Legionella is that the risk is not normally the hot water cylinder itself, it's actually the shower heads. And if you leave tepid water in the pipework leading up to a shower head, that is the risk point. So don't panic about cylinders being the source of Legionella. It's actually normally the shower head. So you just need to be aware of that. Also, if you do have hot water cylinders storing hot water, really important to insulate all of the pipework running up to the cylinder as well. If you the building regs would say that you should insulate the pipework to within about a meter of the cylinder, but just go ahead, go overboard, insulate as much as you can, because that heat will creep up the pipes and find its way out of the cylinder that way instead. If you've got boilers that are heating common lobby areas and social areas, to get a boiler operating in its most efficient mode, what we call the condensing mode, it's really important that the water that comes out of the boiler is as low temperature as possible. So what we want is the boiler water to go out hot and come back below 55 degrees Celsius. And if you can't get that low return temperature happen because of your central heating design, it's the difference between your boiler running at 90% efficient or 80% efficient. So if you've got any people associated with the club that are involved in plumbing and heating, really be a really good idea to get them along and come and check over your system and see if you can't tweak that to get it running as efficiently as possible. I just put that little fact in there as well about the turning room temperatures down 1 degree. In Tyndale's bills, that could have been the difference between £500 and £600 saving, having it at 19 degrees versus 18 degrees. One other thing you might want to consider, controversial, do you actually need to heat the away team showers? I'll leave that one for you to decide. So next, we're going to move on to energy efficiency with electricity. And one of the great things about electricity is you can measure it very easily. So it's much easier to track down problem areas. When I looked at the bills at Tyndale, I could see the main uses of electricity were floodlighting, like we showed in the graphs before. And then the rest of it was mainly around chillers, fridges, freezers, cooking, and also that big lump in June time when you were hiring out facilities for other events. I would say that there's a risk that if you're not charging much for hiring out your facilities and they're using loads and loads of electricity for whatever it is they're doing, there could be a risk that you're not making anywhere near as much money out of that event as you might think. So it might be worthwhile just tracking how much electricity is being used when you are renting out your premises to make sure that you're covering your costs as well as you could do. So when it comes to avoiding wasted electricity, again, we've seen already how much of the energy use in your buildings is actually associated with heat, and electricity does provide heat sometimes. So I think I'm right in saying in Tyndale, the away changing rooms are heated electrically, even though the common areas are heated by the gas boiler. The heating in the away changing rooms is done electrically. Electricity per unit is 21 pence. Gas per unit is at the moment 7.5 pence under that cap that we spoke about before. So you might even want to think about moving away the away heating, the away changing rooms heating over to gas in that situation, because it's a third of the price of electricity. Whether that's practical or not with the boiler arrangements you've got there, I don't know. I'd need to go and look at the building. But just remember that electric heat is expensive and gas heat is relatively cheap, as long as we're not talking about heat pumps. But I'll go into that in a little bit more detail later. For your lighting, make sure it's only operating in nighttime. You can get occupation sensors that make sure the lighting doesn't stay on when there's nobody moving around the building. Automate everything that you can to make sure that lights aren't being used when they don't need to be. Low power appliances as well. If you're replacing kit in the clubhouse, always try and find those appliances which have got a good energy rating on them. We're going to talk a little bit more now about actually monitoring energy. So I think I'm right in saying that when Steve and Sean come to talk to you later, they're going to be giving you some idea about how you might be able to track down energy use in your building through the electric meter. Any large commercial building has what we called half-hourly metering. And what you can see on this graph here is a business that's using half-hourly metering, and I've just taken their energy use. So we get a reading every half hour throughout the day, and then as you move down the page, that's different days in the year. And I've just colored these cells so that you can see for this particular business, it's very obvious. They start work at 7:30 in the morning and they stop work at 4:30 at night. You can use these sorts of techniques to track down energy use in your building as well, once you've got access to that data. So many clubs won't be in a situation where they would normally have half-hourly metering, but if you don't have access to half-hourly metering, what you can do is buy other equipment that does exactly the same thing. And I would argue that, in fact, that sometimes this information, which is in far, far more detail than you get through half-hourly metering, would be potentially quite a lot more useful to you, especially if you're trying to track down energy use that you're a bit confused about where it's going. So in this case, this is a platform from a company called Owl Energy Monitors, and it's giving you that information every minute instead of every half hour. And you can see individual spikes there of individual appliances turning on. So you can get quite a lot more information out of some kind of system like that. They don't need a professional to install them, though. If you're confused about electricity, obviously don't do anything that you're not comfortable with. They are designed to be consumer devices. And once you've got the sensors set up on the electricity meter, all it involves then is just setting up an account online and connecting that device through a small hub to the internet, so that you can access all of this information online and then download it into spreadsheets and have a better chance of trying to track down what's going on. Some of the bigger buildings, you might find there's multiple distribution boards. So you might start off looking at energy use at the main point of incoming. And then once you're trying to track down faults, if you think you've got problem pieces of equipment that are using too much energy, you can move them across to each individual distribution board and then really see what's going on, eliminate things from your inquiries and track down those problem loads. Excuse me. So many of you may have thought already about trying to put solar systems onto your properties to try and cut down on energy use. So I'm just going to talk a little bit here about the practicalities of doing that and what the impact on your bills may or may not be in that situation. Before we go into that, we're going to go into another poll. Are you already considering solar or heat pumps for your buildings?
Yeah, thank you, Ben. And the poll is with you now. And on this one, it's important to remember you can answer more than one. Okay, so you can answer as many on here as you would like to. So it makes it a bit more difficult to sort of know when you're finished. However, you answer more than one. Like I say, any problems at all, put your answer in the chat. We'd love to hear from you. So I can see what's coming in now. So let us know, what are you considering on solar and heat pumps? Is it solar PV panels, heat pumps? Is it solar water heating? Or is this all new to you and it will be something for the future? So I can see that's sort of slowing up now, and I'm just going to end that poll and then share those results with you. So quite a lot are considering a lot out there, particularly solar PV panels with 68%, but yeah, heat pumps, less so solar water heating, and some are not a bit sure there. So back over to you, Ben. Thanks very much.
Thanks, Alex. Okay, well, hopefully you'll find this next bit useful. So this here is an overhead view of the Tyndale Club. You can see they've got two buildings there, the stands and the main clubhouse. I knocked up a 3D model here. We're putting some theoretical solar panels on there. So you can see what can be possible. There are solar panel mounting solutions for literally any kind of building you can think of, whether you've got flat roofs, pitched roofs, metal roofs, cement fiber roofs, asbestos roofs. There is potentially a solution, though asbestos is going to be an expensive problem to solve when you start trying to get rid of asbestos roofing sheets, which you will inevitably do if you start trying to put solar panels on top of those. It's just much simpler to replace them than to work with them. Right, the key point I want to get across here is that the situation we are in now with solar panels and where we were 10 years ago is completely different. When there was the incentive scheme called the feed-in tariff, the approach to sizing solar systems was completely different. In that situation, you got money whether you used electricity or not, and then you got an extra small amount for what you exported, and then you also got the benefit of what you used inside the clubhouse. We don't have that scheme anymore. the only money that the only benefits that you get now are what you use yourself and what you export. And the difference between those prices is quite significant. So you can see here on the table, under that support scheme, electricity is 21 pence a kilowatt hour, or exported energy that you sell to the grid is about 5.5 pence a kilowatt hour. Pretty big difference there, 4 times as much. So the emphasis now is much more on sizing the solar system to make sure that you use most of what it produces, and that's the way to get the best value for money out of a solar system. So on the left hand side, I put in some real kind of line in the sand guess at what the installation cost for different system sizes would be. Now, I used to work as a solar installer, so I'm pretty confident that these are realistic prices. And we've got, starting here on the top, 1 kilowatt. Nobody installs a 1 kilowatt system. That's about 3 panels nowadays. But it's just there to give you an idea of what's going on here. And then right down at the bottom, we've gone all the way to 100 kilowatts. And to be honest, most clubs wouldn't even be able to get 100 kilowatts onto their roof. That represents a really big surface area, maybe 500 meters squared of solar panels. But you can see in this picture that I've painted here, on the left-hand side, where that 5% column is in red, the numbers underneath 5% are telling you roughly how long that system would take to pay for itself. So if you've got that solar system on your roof and you only use 5% of the energy that it produces and sell the other 95% at 5.5 pence, it's going to take you somewhere between 13 and 15 years to pay for itself. Conversely, on the right-hand side of the graph, if you size that solar system so that you use all of the energy coming out of it and you didn't export any, you'll be looking at payback periods under 5 years. So your aim as a club would be to put a solar system on the roof which maximizes the amount of energy that you use yourself. You don't put in a really big system. You've got to size it correctly for the needs that you've got in your clubhouse. And again, going back to that energy monitoring that I showed you earlier, if you're armed with that data showing you how much energy that you're using the building, and most importantly, what time of day you're using it, that is the route to making sure that you get a solar system that's the right size for you. In my modeling program, I took some of the information from Tyndale again, and what we have here is 2 graphs, one from the winter, one from the summer. Rather confusingly in this graph, the solar energy is in blue and the energy used in the building is in yellow. And you can see in the top graph there that all of your energy use in the clubhouse is basically crunched up towards the end of the day. It doesn't overlap with the solar production in the middle of the day at all. That is inevitable. It will happen. You know, there is less solar energy in the winter. We all understand that. On the graph below, you can see here there's quite a good match. So the solar energy is outstripping the amount of energy being used inside the building by a significant amount. You might argue that this may be too big. So we've got a fundamental problem here. Rugby clubs don't have a great profile for matching with solar systems. You've got high use in the winter, not in the summer, and you've got high use in the evening, not in the daytime. And for some clubs where you've gone down that route of having combi boilers, storing water safely is not practical. So putting energy into stored hot water is not an option for you either. This is a picture over the whole year. Again, I would argue that, and again, this is Tyndale's bills that we've got modeled here. I would argue that a solar system that's producing that much solar energy is actually too much for Tyndale, because you can see the large orange area there that's not overlapping with the blue part, which is the energy use inside the building. You've just exported all that energy and sold it away for a really cheap price. You'd have been better off sizing that solar system a bit smaller and making sure that you used a much higher proportion of it. There's one other thing that I picked up at Tyndale that I think was worth talking about as well. So in the top picture here, what we've got is the clubhouse, which has got 1 meter with the day and night rates. And then there's 2 other meter points. Jonathan, apologies if I haven't modeled this exactly correctly to suit your situation. I'm talking about a theoretical situation here. It doesn't really matter if it doesn't match what happened at Tyndale, but I just want to get the basic principles across to you. Right now, if you put solar panels onto the main clubhouse, the building top left in blue, you could put on solar panels there, and the solar panels there would feed everything that's fed from that 1 meter. And then if you went to the smaller stands over on the right-hand side, in the middle of the rugby pitch, there's another meter over there, I assume. And you could fill up that building with solar panels as well. But those are 2 completely separate situations, and you'd be looking to size the systems to match the consumption at each of those different meter points. You can see there's also another meter going off around and feeding the floodlights around the edge of the pitch there as well. Now, what we could do in Tyndale's situation is rationalize that electricity supply and move to the situation below, which is where the electricity supply coming in goes to the clubhouse. And then rather than having another 2 meters located in other places, everything is fed off that 1 meter. And then you can put solar panels wherever you like, and they will all be benefiting all of the buildings rather than having to consider them all in separate cases. So obviously you'd have to weigh up what the cost of doing that would be and what the benefits of putting the solar in would be, and spreading that benefit around. It's not, it's not something I can easily do for you. It's something that's very individual and would have to be done on a case-by-case basis. But moving to that second situation, not only have you allowed more solar panels to be put on in more locations, helping more of the buildings, you've also got rid of 2 of your standing charges, simplified your billing situation, and hopefully made a much more sensible system out of the whole thing. When we look at the breakdown of charges, some of you might be interested to understand how much of the bill is electricity use that you can, electricity charge that you can reduce by not using it, and how much of it is standing charge and how much of it is climate change levy. The standing charge doesn't go away. We used to be looking at standing charges of about 20 pence a day a couple of years ago. I think you'll find quite normally now those standing charges are creeping up to sort of 50 pence a day. That's unavoidable, but obviously you can avoid using normal electricity, and the climate change levy is linked to how much electricity you use. So when you reduce your main energy use, you're also reducing climate change levy as well. I also worked out that the standing charges, if we talked about that situation where we removed 2 of the meters and just consolidated it all back to a single meter, you'd probably be avoiding around about £600 of standing charges. When we put a solar system in, we need to think a little bit about how the electricity arrives at your door. Some clubhouses will be big, some will be small, some will be on a domestic single-phase connection. Some of them might have much larger connections, which we call 3-phase connections, the same sort of thing that you'd find in a factory. The DNO, or so if you're in the region that I'm in, that would be Western Power, are responsible for all the cables that make their way to your door. But if you start trying to put in large solar systems, and you've only got a fairly insubstantial electricity supply going to your building, you may find that to get the right size solar system, you're going to have to upgrade that very last part of the journey from the transformer to your door, and that can potentially be expensive. And when you go to solar installers, they can't tell you what those costs are until they start making inquiries to the DNO for you. So you just need to be aware that when I was talking about those installation prices earlier, that was just to put the solar system in. It's not to do with upgrading your connection if you need that. So you'll normally find that installers can go and make these inquiries for you and find out what any upgrade costs might be. If you've already got a 3-phase connection there, you'd probably be absolutely fine. And there might not be any need to upgrade it at all. But once you start getting over about 50 kilowatts of solar PV size, then it's quite likely that connection might need to be upgraded, and there's a cost there that needs to be considered as well. I've just brought up that slide again, but we've got some little bit more information at the bottom here. So I modeled 2 different solar system sizes here, and in one case we had 28% self-consumption in the circle at the top there, and then in the other situation, when I'd reduced the solar system size, we got that consumption up to 60% self-consumption. So that's, when I say self-consumption, I'm talking about the solar energy coming off the solar system and into your building and being used by you, saving you 21 pence per kilowatt hour. So if you remember the graph that I showed you earlier, that could be the difference between payback in 4 years or 8 years. So it's really important you get this stuff right. Another thing you guys may be considering is moving over to heat pumps. Now, when it comes to the hydraulic designs and services provided in the club, there's going to be so much variation that, again, all I can say is I'm talking to you about what might be possible in some cases. It's not necessarily going to apply in all cases. A lot of people get very confused about heat pumps, so I'm just going to go through a couple of basic technical terms. One thing people will talk about frequently is the coefficient of performance. you can think of that as being a bit like the MPG test for a car. It's the efficiency of the car at a certain speed. Another phrase that gets used almost interchangeably with coefficient of performance, or COP, is SPF, which is seasonal performance factor. And it's kind of the same as a COP, but instead of it being at one time in the year, or on one day, or at one speed, if you like, in the car, it's the performance of the heat pump over the whole year. So it's a bit like the urban cycle of a car in performing in different situations. So when we talk about heat pumps, a very, very standard way to think about it is that for every unit of electricity that you put into the heat pump, you get 3 units of heat out. But that's not always true in all situations, and it's especially not true in a rugby club. So I'm just going to explain that a little bit better. But maybe an easy way to think about this right now is that if electricity is 33 pence a kilowatt hour and gas is 11 pence a kilowatt hour, and if you put a unit of electricity into a heat pump and you get 3 units of heat out, that means that in this situation, 33 pence and 11 pence, they're going to run at the same cost. But looking back to the slides we did earlier about what the actual support costs are for you at the moment, electricity is actually 21 pence and gas is actually 7.5 pence. So I've done an illustration to model that for you right now. On this graph here, sorry, I know it looks a bit complex. I'm going to talk you through it. In the red box, I've programmed in the support price unit amounts for electricity and gas. I've assumed that any gas boiler would operate at around about 84% efficiency. That's, although many people might think that boilers operate at 90, 92% efficiency, we know from the real world that mostly boilers operate a bit less than that, and 84% is pretty much the average efficiency for a boiler. In the graph below, what I've got here in the grey is the price, the cost of gas for providing heat. So in this particular example, the dark grey line at £8,000 is what it would cost to do the gas bill at Tyndale. The green line that's moving from left to right across that graph is how much it would cost to run a heat pump to deliver the same amount of heat. But on the left-hand side, we've got a heat pump running not very efficiently. And on the right-hand side, we've got a heat pump running very, very efficiently. But you can see right now, that heat pump at those prices is running more cheaply than the gas boiler. Now, obviously, I can't say what's going to be happening in 2 years' time or 3 years' time or 4 years' time, but I can say right now that a heat pump would run more cheaply than the gas boiler. It's slightly different for houses. It's still basically the same kind of picture, but because the unit rates are slightly different, and proportionally speaking, electricity is slightly more expensive under the domestic caps, a gas boiler would still be more expensive than a heat pump in most cases, but the difference between the two is a bit tighter. So I've drawn a red line on there as well, an arrow pointing down for typical efficiency. I reckon that's probably what you would find in the typical rugby club, although a house heat pump might be working at a ratio of 3 to 1, slightly to the right of the red line. I think because so much hot water is being produced for showering at high temperatures, it would impact on the performance of a heat pump. And realistically, you'd probably be looking at a performance ratio of 2.75 to 1 rather than 3 to 1. So that's where I put that red line. But you can see there's still quite a dramatic saving to be had moving over to heat pumps. Now, of course, heat pump installations are very expensive. I'm not telling you all to go out and get heat pump installations. I'm just letting you know that right now they do offer a reasonably substantial saving over heat pumps. And of course, the next question that comes out of that is, well, what's it going to be like in 3 or 4 years' time? If you were to go and speak to the government and ask them the question, which is going to inflate in price more quickly, gas or electricity, I think you'd find that the answer would be gas is going to inflate more quickly than electricity. So my personal opinion is that putting in a heat pump is not a bad idea, even if it is a very expensive idea, because as long as that gas keeps on inflating more quickly than electricity, the running costs for heat pumps are always going to be lower. So just to talk a little bit more around that ratio between water or coming out of the heat pump at different temperatures. On the top little table here, I've got a high hot water use and low central heating use. And the seasonal performance factor, that ratio of electricity to heat, is 2.6. It's not that great because most of the heat coming out of it was produced at 60 degrees to heat your hot water cylinder, and much less of it was produced to do the central heating at lower temperatures. Conversely, on the table below, we've got low hot water use, because maybe you don't have any stored hot water there, or there could be a number of reasons why that might be the case, but you've got a very high central heating use. The central heating use is much more efficient for the heat pump. You end up with a different seasonal performance factor, and then your bills end up lower as a result of that. So if you flip between those two different situations, running the heat pump in one situation would cost you 7,200. In the other situation, it would cost you 5,900. So it's really important to think about this thing. Are we going to be using mainly hot water or mainly central heating from our heat pump to provide the services that it needs to in the clubhouse? Because that's going to dictate how efficiently the heat pump runs and therefore what your bills will be. So this slide is talking a little bit more around self-consumption of solar electricity and heat pumps. On this slide here, we've got three situations. I actually modeled this for a house rather than a rugby club, but the basic principles apply. If you just put a solar system onto a house, you may well get around 27% of the solar energy going into the house and saving that person 21 pence a kilowatt hour for every unit that came from the solar system and was used in the house. If you then add in a heat pump, your electricity bill goes up, your gas bill disappears, but you're also affecting the amount of solar energy that can be used. You've increased your electricity use. That gives you opportunity to potentially put in a larger solar system and use more of that electricity in your heat pump. So when I added into this house a heat pump rather than the gas boiler, the self-consumption of the solar energy went up by 55%, and to 55%. And then you're increasing the payback of your solar system, reducing the payback of your solar system. The solar system will pay for itself more quickly because it's doing more useful work. And then in the third situation at the bottom, I imagine then putting a battery in as well. And in this particular case, though obviously it needs to be modeled to suit your circumstances, self-consumption of the solar energy went up to 95%, and the solar system was providing nearly 30% of the energy, of the electricity being used in the building. So obviously you need to get somebody to come and look at this situation in detail, but that's the kind of dramatic scenario changes you can see based on adding in different technologies that work together to help you reduce your energy costs. Many of you may well know about Eaton Manor. I had a chat with Martin about that before the presentation was being organised. If you don't know about Eaton Manor, I'd encourage you to go and do some Googling on it to look at the case study there about what happened. They had a really, really intelligent system going on there. And unfortunately, you won't be able to replicate that because they were able to make even bigger savings by utilising the feed-in tariff and the renewable heat incentive for producing their heat. But if we ignore the money side of things and the extra benefits they got from the subsidy system, basically what happened there was solar energy, the icon in the middle, went down to power the heat pump. When a heat pump runs, it produces heat. It also produces cold. There's two sides to a heat pump. It produces heat, and while it's producing heat, it's also expelling cold, if you like. That's not a very great way of describing it scientifically, but that's the way to think about it. So in Eaton Manor, what they did was they used the heat to provide hot water for the showering and heating in the clubhouse, and they took the waste cold and used it to chill a tank. So they had two tanks, one hot, one cold, and then from the chilling tank, they also used that to help cool the beer cellars. So this was like the holy grail of efficient energy use. You had free solar energy coming in to the heat pump. They were getting paid for producing that solar energy by the feed-in tariff. They were getting paid for producing the heat that went into the hot water cylinders and the heating. And at the same time, they were using the free cold to help keep the cellars cold at the same time. Coincidentally, I actually worked on that installation at Eaton Manor. I know the company that put it in, and I did some contracting work with them. And I was actually crawling around in the loft at Eaton Manor, helping to run the pipes from one place to another. Getting towards the end of the presentation now, I just thought I'd put this graph up here to show you the difference in cost and carbon between different heat sources as well. So on the left-hand side, we've got an electric boiler that would be running in the daytime. You can see there that the cost, the green bar, is really, really high. It's higher than anything else. Electric boilers are really expensive because they're running off electricity at 21 pence a kilowatt hour in this case. If you move across to storage heaters, they're obviously running at nighttime on cheaper rate electricity. That drops the cost off compared to an electric boiler quite significantly, but it's still pretty expensive. If you then went to gas, That's almost as low as you can go in terms of heating costs at the moment. And then if you move across to a heat pump, you can see it's a little bit better than gas, but not much. If you want to be interested in the carbon emission savings instead, that yellow line is telling you everything you need to know. When you put in electric storage heaters or electric boilers, there's no, they operate at roughly 100% efficiency, but it's relatively high carbon to produce that energy. Because the heat pump's only using 1 unit of electricity to produce 3 units of heat, it actually ends up being greener than gas quite significantly. So moving across from a gas boiler to a heat pump will reduce your carbon dioxide emissions by somewhere between 60 and 70%, depending on how efficiently you get that heat pump to run. You can see on the right-hand side here, when I created that graph, I was actually using the domestic price caps, not the ones that you've seen earlier for the support mechanism that you're able to access. So just to summarize then on energy efficiency, not using energy is the cheapest way to save money. Heat is often the biggest source of wasted energy. Remember, I spoke about insulating pipework in cold areas and so on, reducing temperatures. Automate and use thermostats and timers wherever you can, so you don't have to think about it. Anything that you can take out of the realm of the human and get a machine to do it for you instead, usually that's a much surefire way of making sure something gets turned off than relying on somebody else to do it. Measure and monitor to track down waste wherever you can. If you're talking about measuring heat use, I think putting a heat meter onto the boiler to measure how much energy a boiler puts out is probably not that helpful, because it won't tell you where it's getting lost, where it's getting used, and it doesn't need to be. So quite often measuring and monitoring when it comes to heat is just about going around and doing visual inspections, checking timers and controls, making sure that you haven't got uninsulated pipe runs in cold areas. You can also consider consolidating electricity supplies and meters if you've got that multiple meter situation going on that we saw at Tyndale. And then also I would ask the question, do your events actually cost you money rather than make money if you're renting your facilities out very cheaply, but the users are actually using stacks and stacks of electricity in that period? Summarizing around renewable energy, self-consumption is the key to making solar work for you. Having accurate meter data will be really, really useful in making sure that the solar system gets sized for your needs at the club, and make sure you get that payback period down as low as you possibly can. Again, consider consolidating those electricity supplies so that different buildings and structures can offer up their roof space to make the most sensibly sized solar system to meet your needs. And think about a journey as well. You may well not be able to do some or any of this stuff right now, but it's really important to think about the journey that you're going to go on from one place to another, moving from that, I've got 4 meters, 4 sets of standing charges, to consolidating everything to what makes the most sense, a solar system first or heat pump first. I can't answer those questions. That's something that you're going to have to do by finding local contractors to come out and speak to you about this stuff, or maybe even employing an energy consultant to come and do the detailed work for you yourself in a way that you can completely trust. But if you do this stuff right, there's absolutely a route forward to significantly reducing your bills and also reducing your carbon emissions as well. And that's it for me. Back over to you guys.
Thanks, Ben. Guys, there's lots of amazing questions coming into the chat here. And I think we're mindful of time, and we're also mindful of the fact that there are lots of different circumstances relating to different clubs. So some of the questions are quite specific and quite technical. So the ability to try and answer them all in one go is going to be quite a challenge for us, but that's really, really good. So please do keep the comments and the conversations and the questions going into the chat, because that's really helpful for us. Because I say, we take it away and we look at it and we try and work out what we can and can't do. There's some questions in there which you can imagine from our perspective. I'm club business manager. I'm not an energy advisor. I'm not a heating engineer, but we'll go and find that information for you. And the key thing for us is we can make sure that clubs are more informed, because, as I say, and as Ben's alluded to, each of your individual circumstances are very, very different. Spencer, just answering your question, yes, it will be the recording will be available afterwards. One question that I'd like to, at one point I'd like to put in now, if I may, before we just move on to Steve and Sean from Positive Energy, is, can you just think in the chat any other areas or topics or themes on this topic of energy that you would like us to cover that we've not covered? And I know there's a huge area, but anything you can think of, just think, yeah, I'd like to know a bit more about that. And there's been questions about LPG, about oil, and so on. Anything you can think of, just put it in there, and we'll try and go away and find where we can. As I say, we're not the experts, but we'll try and find that information. So just put it into the chat as we work through. In terms of questions, Ben, I think what we'll do, we'll wait towards the end if any specific questions. So I'll give you a little break, let you get a drink and so on. But guys, just keep throwing those points in about grants. I can see different types of renewables and so on. But what we'll start to do, or what we'll do now, sorry, is I will transition across into our next speakers. And so basically it gives me great pleasure to introduce our newest commercial partner at the RFU, Positive Energy, as I mentioned at the beginning. And from Positive Energy, speaking tonight, we have Steve Daniels. Steve is the Chief Sales Officer and co-founder of Positive Energy. And we've also got Sean Newbold as well. And so without further ado, so Ben, if you can stop presenting on your slides, and then what we'll do, we'll switch across. So Steve, over to you. I'll turn my camera off and I'll leave you to talk through with the rest of the guys.
Great, thanks, Mike. Hi, everybody. Great to be with you this evening. Yeah, as I said, my name's Steve Daniels. I'm the CSO, Chief Sales Officer for Positive Energy. I'm also the co-founder and one of the owners. Yeah, so delighted to be here this evening. I myself have been involved in rugby for circa 30 years now, from playing to coaching to being on a committee. So I fully understand pressures that clubs are under, particularly at the moment of, quite frankly, an energy crisis that we're in. We've come on board, hopefully, the RFU to really help clubs, and it's something that I'm really passionate about. Rugby is my thing. My kids play it. We all play it. We're really conscious of grassroots rugby and how we can, as a business, help wherever we possibly can. A little bit about Positive. We started trading back in 2017 from a standing start. With zero. Myself and my four colleagues were energy brokers before, and quite frankly, we set the business up due to the inadequacies we saw in the energy market. So we've come in with a very tech approach to energy, and added something that's probably quite different to what was in the market at the time. So fast forward to today. We've got 115,000 B2B sites. We've got 5.2 terawatts of gas and power under supply. In residential terms, in house terms, that's equivalent to about 1.5 million homes that we power and gas. We're the UK's largest independent supplier now, and we're quite unique in how we operate, very tech-led. And it's something that enables us to keep our prices down. And we offer a whole range of services, and we're going to touch on some of those today. But in terms of procurement, that's one of obviously the key part. You've got to buy the stuff as cheaply as you possibly can, and that's something that we're here to really help with. We've got some very aggressive priced tariffs specifically for the RFU, for grassroots clubs. But let me introduce you to Sean. He's one of our directors, and Sean now is going to talk you through specifically the EBRS scheme, and hopefully put to bed a few of the myths and give a bit of clarity, hopefully, where it's been somewhat of a complex time, shall we say. Sean, over to you.
Thanks, Steve, and thanks, Ben, as well, for your presentation. You've actually team line up quite nicely, so to speak, because of some of the areas that you've mentioned actually cross over from what we're going to go over now. What I want to touch on today specifically is the energy support scheme for businesses that's been announced recently. Just to give a bit more clarity, there's been a lot of speculation, a lot of uncertainties, not just out in the public and businesses, but also from supplier level. But the government have given more transparency over the course of the past couple of days, which I'm just going to go over now. So what I want to do first is just to cover off and to touch on what Ben was related to on some of his slides, and to give an understanding of what's happened in the market over the past 2 years. This graph here is from ICE, which is, this is the wholesale prices, and this is particularly gas, but as you saw by the previous slides, electricity follows a very similar suit. So we're looking at January 21. So this over to you. This covers over the past 12 months that I've taken this. January 21, you were looking around 45 pence a therm. In new money to yourselves, that's 1.53 pence a kilowatt hour. That's the wholesale cost of the gas. In January, that actually peaked to levels that we hadn't seen since the beast from the east in 2018, which was for a 5-day period and had a dramatic impact. And that went up to £3.27 a kilowatt hour, sorry, a therm, which in new money is 11.2 pence a kilowatt hour. And in the back end of the year, it dropped down again, coming through January, rose again in April, and it peaked again in October this year at £7.88 a therm, which is 26.89 pence a kilowatt hour. The markets have eased off a little bit now. There's still a lot of uncertainty in the markets. And what we've looked at here is what we're seeing going forward over the coming years. So where the prices were on the previous slide down at your 44 pence a therm, £1.53 a kilowatt hour, what we're seeing now is the prices slowly reducing through next year into 2025, 26, 27, and coming down, but only leveling out that we see now in a 5-6 year period to your £1.50, £1 marks. We don't know, this may change. We don't know how this will impact going forward with any further activities in Europe, overseas, and also our own supplies that are needed. So just wanted to pitch a little bit of the picture there as to where we've been and where we see it going forward. As mentioned in the slides by Ben, the government have announced the support scheme. A lot of people are here referring to this as a price cap. It isn't a price cap as in the domestic world where people will not pay over the base level set. What the government have done for electricity, what the government refer to as the supported price, I refer to it as a base level or a floor level, is 21.1 pence a kilowatt hour. In the gas, it's 7.5 pence a kilowatt hour. If you're on a deemed and variable contract, what that means is you're paying at the moment for your gas and electricity at the monthly rates. It can change each month depending on how the market goes, and your supplier can do that. Your benefit is that you're not tied into a contract and you could leave at any given time. The government have set their discounted prices of 34.5 pence a kilowatt hour for electricity and 9.1 pence per kilowatt hour for gas. These have been calculated on the wholesale market reference price over a 10-day period, over a 10-day average, up to and including the 30th of September. What this means is you will get that discount or the maximum of that discount until you reach that floor level. So if your supplier is charging you 50 pence for electricity and the actual floor level is 21.1 pence, you will get a 28.9 pence discount, not the full 34, because you're not allowed to go below the government support floor price. So you will get a maximum of 34.5 pence in electricity, or the maximum of the 9.1 pence in gas if you're on deemed, as long as it doesn't take you below the government floor price. The government recently, and I saw a couple of questions pop up there. I think one was from Paul, question about the government support scheme for fixed contracted prices only being from April. One of the changes, as recent as yesterday, the government are now extending that to contracts signed from the 1st of December 2021. They've recognised there was some large exposure areas before April, and they've made that decision to extend it. So any contract signed on or after the 1st of December 2021 will be eligible for the government support, as long as it doesn't take them below the actual level of the floor set. So looking at this, this is indicative when I put this together, what we have done, and for the actual slides to be shared out, we've actually put a link to the actual government scheme, the actual published as of yesterday discounts available. These prices here were indicative at the time of what they were aiming for. As of yesterday lunchtime, we got the exact discounted prices. It was a little bit too late to start changing the presentation, so we've popped a link on there. What we will say is, if you do want any advice or any understanding as to whether you are covered, there is a dedicated phone number on the website, a dedicated email address. We've got a team on standby. We'll be more than happy to support and help you, to give you an understanding on an individual basis what the scheme actually means to you. But what the government have decided and what they're saying for fixed prices, they're doing it on a daily basis. So unlike the deemed rates where they're saying it's one price fits all, what they're doing is giving a date range from the 1st of December, going all the way through up until the end of September, beginning of October, where the wholesale prices can be defined. They're taking the wholesale price as was at that time. So as an example here, the 1st of April, they're saying the wholesale price for gas was 9.35 pence. The government supported price was 7.5 pence. Therefore, you get the 1.85 pence discount, because that will take you from the 9.5 down. If it was the 25th of June, they're deemed that the wholesale price was 11 pence. The government support price is 7.5 pence. Therefore, the difference between the two is 3.5 pence. If on the 25th, and this is based on the government wholesale price, if on the 25th of June, you signed a contract that was a longer term contract to maybe 3 or 4 years, and the price you're paying was only 9.35 pence, as in the 1st of April example, you wouldn't still get the whole discount, because by applying the whole discount, it will take you below the government supported floor price. Hopefully that makes a bit more sense going through that, but we have got the full table there with the discounted prices, which now go from the 1st of December, and we will be there if there's any calls or email come through. We might need some data from you to be able to look at what yours will be, and we'll be able to support and help you as to understand better on an individual basis what your discount should be getting applied to your current bills. Question being asked. Oh, so just before I go into that, one thing as well that's worth noticing for anybody that's going to renew. We're talking here about contracted prices when you sign the contract. If you get a renewal offer from your supplier, the deemed price that you're paying is your renewal offer, not the date you signed. So if your supplier offers you renewal of a certain price, let's say for argument's sake, 12 pence, and you don't sign it on that renewal offer, and you sign a later date where the price has actually gone up, your contracted price will deemed to be the 11 pence, because that was the offer and the chance you had of signing at that time. So that's just worth bearing in mind on renewals where it's renewal with the same company. Question we get asked quite a lot is, what do you need to do? You don't need to do anything. The support and the rebates will be automatically applied to all eligible bills. So you don't need to take any action or apply to be a member of the scheme. Your supplier will look at the discount. They will apply it against your unit rate that you've charged. That unit rate is inclusive of any commodity, any other elements other than VAT and CCL charge. So rather than the suppliers work out what the wholesale rate is that they sold it to you, it will be applied at your contracted rate, less the VAT and CCL. You will usually see, so the scheme started on the 1st of October. Most people, the way that the business to business is built, will see their first rebates from their bills in November, which usually come from the 1st of October to the 31st of October. So hopefully that will give a little bit more of an understanding on that. If there are any questions, we will get through them and get to them. What I'll do is hand quickly back over to Steve now.
Thanks, Sean. Yeah, so with this, obviously, it's down to your energy provider. Let me share my screen, actually, Sean, because I'll start my, if you can stop sharing. This is obviously down to your individual energy provider to provide you with this information. I'm just going to share my screen now and show you what we can do. Sorry, it's gone. Bear with me, sorry. So, yeah, sorry, guys. So, your supplier obviously is responsible, as Sean has just said, to provide you with this information on your bill. The issue you've got is that a lot of energy suppliers' bill platforms aren't particularly sophisticated. And it's quite widespread that errors happen, errors occur just in normal billing. Now, this has been, for a lot of suppliers, rushed through. And it's something that you need to be much aware of, really be aware of. So we're offering a free bill validation service. MPAS is our technical arm of Positive Energy, and we're offering all of the RFU grassroots clubs a free bill validation service, basically ensuring that what you are getting billed is right, proper and correct. And it's really important at the moment, more so than ever, with the cost of your supply, that you are actually paying really for what you should be paying. Add in the EBRS, making sure that you're getting the correct discount as well. So it's really, really important that you're actually getting the correct bill. This service is something that we're offering, as I say. It helps cash flow as well, and saves you getting tied into long protracted issues with your incumbent supplier. We validate your bill against your current contract rates, consumption, the static information as well. But as I say, the key thing is that the EBRS is actually checked to make sure that you're already paying for what you should really be paying. Really simple process. You email us a copy of your full energy contract. Hopefully on that, not all do, but hopefully you will have the actual date that you signed. And that's the key thing with this whole scheme with EBRS, is actually when you signed the contract, not when you went live. And this is one of the points where I think a lot of people get quite confused. So it's when you actually signed the contract. So hopefully if that's on your actual contract, we can then validate if you are eligible, of course. If you are eligible, what is the actual rate that your rebate, and make sure that that has actually been applied correctly. So very simple. You email us a copy of your full contract, then you email us an energy bill every month. We validate it. We then simply email back to you with the results of that. Hopefully everything's absolutely fine. If it's not, there's an exception report, so we actually show you what is actually incorrect. You can then just go back to your incumbent supplier and even send them a report and say, this has been independently validated. Please can you check this? Hopefully that solves that issue, and you get what you should be getting. That's it really. So it's a very straightforward service. It's something that we're offering. It's free. Give it a go by all means. Contact us at Positive. We've got a dedicated team here for the RFU for clubs, and it's something that, as I say, we're really passionate about. Really looking forward to working with everybody. If there's any other related things that you want us to look at, procurement, Ben mentioned about smart metering, or we can offer smart metering, of course. Sub-metering is a really important thing. There's a whole host of things you'll see on our website, from EVs for rugby clubs, et cetera, et cetera. So do feel free to peruse the site, and if we can help in any way, then please do get in contact. And I think I'll hand back to Martin, if I may.
Thanks, Steve. If you want to stop sharing, brilliant stuff. Well, first of all, can I thank all our presenters tonight? It's a very, very complex area with lots of different elements to consider. So hopefully that's give you a flavour of some of the points that we want to try and get across. If we've not covered something, then please put it in the chat. Don't be afraid to pop that in there. What I would say is something that we're really sort of keen to ensure all clubs do, and I don't know if you've seen them. I'm actually going to put them in the chat now, but a link onto englandrugby.com on our facilities page. We've got some hints and tips which are no cost and low cost. And going back to the very beginning with Ben's presentation, is one thing we're trying to really make sure is that clubs are actually reducing the amount of energy they're using. So if they can control those costs by doing small pieces of behavior and small changes, and wherever possible, just through behavioral changes, I'd urge you all to go onto the website, click on the link. You'll see 6 different ones which have got a range of hints and tips. You can either keep them on your desktop or print them off and then just them as a checklist. But hopefully those within there will give you some food for thought and start to sort of make some changes. So please keep the questions coming on. We're not going to open it up to general wider questions now, because we're now at an hour and 15 minutes, which is great. Thank you so much for retaining on there. So please, any questions that you've got, let us know. I'll leave the questions and the chat open for probably 5 minutes or so. So if you've not made your point, this is the opportunity to pop it in there. And as I say, what we'll do, we'll take them away, because there's so many, and some of which we will need to dig into and find best advice for you. So if I wish you all a pleasant evening, thanks for listening once again. Thanks to our presenters once again, and hopefully we can start giving you further advice as we get the questions through, and there'll be a follow-up email which will have the link to the presentation and all the slides that we've had. So thank you so much for joining us, and have a good evening.